scientists agree today that the primary cause of the KPG extinction was a bolide impact in the Yucatan Peninsula, today preserved as the Chicxulub Impact Crater. This idea was first proposed in 1980 by Louis and Walter Alvarez, a father and son team who discovered a sedimentary layer at the KPG boundary with iridium concentrations way higher than normal background levels. Iridium is a platinum group element which has much lower concentrations on Earth compared to the cosmos. And elevated concentrations in Earth's crust usually indicate extraterrestrial forces such as meteorite impacts. This iridium-rich sedimentary layer is also marked by impact ejecta, material that had been thrown into the upper atmosphere during the impact and then rained back down on Earth's surface as a layer. This iridium-rich impact ejecta layer is coincident with the very rapid ecological change and disappearance of more than 70% of all species from the fossil record. This preliminary evidence and subsequent research points to the impact as the culprit for extinction. However, there is a competing hypothesis about what happened at the end of the Cretaceous. Large igneous province volcanism, or LIPS, which are periods in Earth's history when unusually high amounts of lava erupts, is the determined cause of most other mass extinctions. Due to the gases emitted during volcanism, LIPS can cause rapid climate change and a variety of other environmental effects. This type of volcanism, LIP, was going on in India during the late Cretaceous and early Paleogene, and thus have some wondering if it could have been the cause of the KPG mass extinction. Gerda Keller from Princeton University has been the principal proponent of the KPG LIP hypothesis, claiming that the extinction was less rapid and the result of climate change was from heavy volcanic activity. This debate has persisted for some time now, and scientists are still trying to determine the exact role of lip volcanism in the KPG extinction. Scientists about their work on the KPG boundary, particularly in one of the best places to study this event, the Gulf Coastal Plain region of the United States. The Chicxulub impact occurred in very close proximity to this region and left behind a detailed sedimentary record of the time preceding the impact, the event itself, and the time frame after the disaster. During the late Cretaceous, climate was much warmer and sea levels much higher, so our study area was inundated by a shallow sea. Millions of years of sediment deposition in the sea is now represented by a sedimentary record that our research group has been studying for over a decade now. In Mississippi, Alabama, Arkansas, Texas, and Missouri, late Cretaceous and early Paleogene sediments are exposed, allowing us to document the KPG boundary in great detail. So let's talk to a few scientists and see what kind of work they are doing in the Gulf and what they have discovered so far. First, we will speak with Dr. James Witz. Thank you for being with us, James. Can you tell us a little about yourself? What do you do? And a little about what you've discovered in the Gulf Coastal Plain about the disaster 66 million years ago.
My name's James Witz. I'm a lecturer in paleontology at the University of Bristol in the UK. And my research is all about understanding how particularly shallow marine ecosystems respond to really extreme environmental change in the geological record. And I'm especially interested in what happened at the Cretaceous-Paleogene boundary 66 million years ago when there was a very big mass extinction event.
Thank you, James. So as we can see in some of this footage, our group has been studying many KPG boundary sites in Mississippi and Alabama, and around the area, we have learned a lot about what happened in the marine realm during this time. But I know that there's a fairly new KPG site in Mississippi, which shows a lot of promise in terms of getting a complete and detailed record of this time frame. Can you tell us a little bit about this site?
Yeah, so there's quite a lot of sites right across the Gulf Coastal Plain where we can study the KPG extinction, but this site is particularly special because it gives us an unusually good record of the immediate aftermath of the impact event, and also of the fossil record of the creatures that were living in the oceans during that time interval immediately after the impact event. So we can see how life in the oceans responded immediately to those really catastrophic things that happened and how they start to recover from that sort of extreme environmental change.
So let's take a look at some of the field work that took place at Trimcane Creek this past year.
All right, last sample from the Prairie Bluff. This one, we're right at the fault. And here again, here's the sample we're gonna take. It's basically right underneath. This is the spheral bed right here. So we're right underneath the spheral bed, maybe like 2 to 3 centimeters underneath. And we're gonna do about a 5 to 10 centimeter sample. So again, right underneath the spheral bed at the fault, and just next to, here's the sample, and here's what we sampled in the burrowed unit. So just aside from there, maybe half a meter less.
Can you tell us a little bit about what these guys are doing?
Yeah, so they were taking samples of rock from before and after the impact event, which we can then analyze in a laboratory, and we can look at, for example, the chemistry of the rocks that record or represent ocean conditions at the time that those rocks were formed. So things like temperature, we can actually reconstruct, and then from those same rock samples, we can extract fossils to actually examine how life was responding to those extreme environmental changes after the impact event.
From 60 to 80 for pollen, and if you look close, maybe even through there, you can see these dark little patches. That's woody material or charcoal. And we're just giving you an idea of how these things are actually then sampled for shipment. We got this saran wrap that works really well as far as mummifying them, keeping it damp and keeping it airtight, and keeping these crumbly samples from drying, because once they dry, they fall apart, and keep them together for shipping. Hey, Stephanie, it's going pretty good.
Awesome. So can you introduce yourself and tell us a little bit about what you do in the Gulf?
Sure, no problem. My name is Matthew Garb. I'm a lecturer at Brooklyn College here in New York City, and I've been working in the Gulf for over a decade now, basically focusing in on studying things that were going on related to the KPG boundary, this big asteroid impact that occurred at the end of the Cretaceous that caused the mass extinction event. I'm interested in anything that related to the environmental changes, ecological changes that we see leading up to and during the impact, as well as afterwards. A lot of the focus, as far as what I've been doing, has to do with what you see behind me here, which are ammonites. So I have a little kind of model here that I'll pop up. Ammonites, they had all these different kinds of shells. People have heard of them in the past, and they basically were squid that lived in a coiled shell, and half the shell were empty chambers that helped them become buoyant in the water column. They were as common as fish, so they were a big part of the ecosystem, and they became extinct at the end of the Cretaceous. They survived a lot of the previous mass extinction events, even the Permian one, the biggest one, they made it through. They were hit hard, but they quickly rediversified after that. So the big question that I'm trying to look into is what happened to them? Why didn't they make it through this one? You know, what was going on? So these ammonites can tell us a lot. One of the things that they're great at, and this picture behind me is of a fossil of an ammonite called Discoscophites iris, which is one of the last ammonites in the Cretaceous, at the end of the Cretaceous. So it was been around when the impact actually occurred. And in certain places in the Gulf, they have original shell. So you can see this aragonitic shell, this kind of pearly looking shell behind me, which is unique. Most of the time, I've also studied them here in the Atlantic coastal plain in New Jersey, and they are basically just infills. They're moldic, what I call moldic preservation, and they don't have their shell. So here's an example of a Discoscophites iris. This one actually got in Alabama in the Gulf Coast, where the shell is gone. So the ones that do have the shell, we can actually do isotopic studies on them that can give us ideas for where they're living in the water column, and also about temperature changes that were going on. So it's an idea that tells us how they lived, as well as environmental changes. So here's one also from Mississippi. This is a straight-shelled one called Eubaculites. It also made it up at the end. So that's one of the things we're interested in. What can they tell us about what was going on leading up to it? The other is, what happened when the impact occurred? So most people think that they basically died out within, decades of the impact. This new site that was talked about before in Trim Cane in Mississippi, we actually think we have evidence for survivors. So we're finding ammonites above the impact event bed with the spherules in it. And they're being intermixed with much younger fossils that are giving us an indication that they might have survived for up to 80,000 years after the impact. Now, that's huge. So that's telling us, hey, these things, they didn't just die out quickly, that they survived for a while, and then something must have happened to stop them from rediversifying, like that occurred at some of the other major extinction events that they were involved with. So what was going on there is a big question. Also, it's still being debated whether they actually did survive or not, whether this evidence that we have is actually real, or is it something else that we're seeing here, or are they reworked fossils? So this is some of the questions that I'm interested in and I'm looking at. So as far as one of the ideas we have is that maybe the ammonites did survive for a time in pockets, but the ecosystem was thrown in such disarray that even though they made it through, things changed in the ecosystem. Competition changed, environment changed enough so that they basically were what's called dead men walking clads. They made it through, but things had changed so much, they basically were on their way out. There's nothing that they can do to rediversify. So there's lots of interesting things to study, and that's related to stuff going on today. We believe we're going through an extinction event today. So if we know what was happening in the past, the mechanisms of these extinctions, it can give us an idea of what's happening today and in the future.
Headed down south to the land of the pines. I'm thumbing my way into North Carolina, staring up the road and pray to God I see headlights. I made it down the coast in 17 hours, picking me a bouquet of dogwood flowers, and I'm hoping for Raleigh I can see my baby tonight. So rock me, mama, like a wagon wheel. Rock me, mama, any way you feel. Hey, mama, rock me. Rock me, mama, like the wind and the rain. Rock me, mama, like a southbound train. Hey, mama, rock me. From the cold up in New England, I was born to be a fiddler in an old-time string band. My baby plays the guitar, I pick a banjo now. Oh, North Country winters keep forgetting me, and I lost my money playing poker, so I had to up and lay. But I ain't turning back to live that old life.